Okay guys, welcome back. So today's lecture we're going to talk about how can we design our database. Okay, so mainly we're going to focus on first talk about the ER model. Okay, so show you how can we design database schema in the first place. Mainly we're going to talk about the entity relationship data model with a high level description of the database. Then after that, I think we have a time to go over this one to show you how can we take the ER diagram or design that we have and transform it into the set of relation schema. Which is going to be end up we have like a relation like student, instructor, and each of them is going to have the set of attributes and etc. Okay, this is mainly textbook. If you have a copy for the 7th edition, it's going to be chapter 6. Okay, so what we are going to go over today, give you like general idea about the design process. Why you need to design database? What we try to achieve? How can I do that? Like with step by step. Okay. Then mainly we're gonna talk about the entity relationships model, which is the one that, as I mentioned, is like high level description of the database. With mainly that we're gonna use in order to help us in order to capture or design the database from scratch, collect whatever information that we have from the user or the domain expert. Then after that, we come up with a design. Okay. Then we're going to take a look at some way how can we handle the different types of attributes, complex, composite attributes, multivariate attributes, etc. Then we're going to talk about how can we enforce some integrity constraints and restrictions, or how can we specify them in my system. Okay. Then mainly we're going to see how can we figure out to find out the primary key in my design. How can sometimes they come up with my design, you see that maybe there's some redundant attributes in entity set in general. Of course, we don't know what do you mean by the entity set, but this one component of the entity relationship model, what you're going to see, sometimes we have some redundant attributes, so how could you, I will show you how to identify them, then after that we remove them. Okay, this is going to be the part one. If we finish this part here, that means this is going to be the phase one, the class project. Okay? Then after that, starting now, we have a design. How can we reduce this design or translate this design into corresponding relational schema or data model? So we end up, we have figuring out our tables. Now, remember when you work with a database or say relational algebra, we assume that we have a university database, right? And we said university database has this like set of relations, and each relation, for example, instructor, student, etc. And you see that for the instructor, for example, contains information about the instructor. Where they're gonna have like a schema, instructor ID, instructor name, and so how can we translate this one? How can we starting implementing our database application? Okay, so we're gonna take a look reducing this one. After we finish this one, this is gonna be like phase 2 of the class project. So in this lecture, very important, it's gonna help us in order to cover class. Part 1 and part 2 of the class projects. Usually we used to teach SQL first, and after that starting to talk about this one. But I believe this is a better idea since we give the student more time to start working on the class project. It's better to start with the design first. Then now, once the student finish phase 1 and phase 2, at that time, hopefully you're gonna finish, the SQL, so the student can work in the final project or the final phase, which makes sense to me at least. Then after that, we talk about the entity relationship model. We see that what I'm going to show you right now, most of the case, we're going to use the simple form. There is extended ER model feature, which is going to cover, I will believe it's going to be next lecture or next week when we take this part. Okay, we talk about some extension we add. The same thing we talk about the relational algebra. We've said that maybe you can add some to give you the basic relational algebra. Then after that, we said we do have like some extra extension we can use there. Okay, or extra piece of operations. Operator we can use. Let me give you like a quick idea, so kind of take a look, see what kind of design issues maybe you can face. Okay, then they give you different notation for modeling data. They give you one model, way how to model the data, and then go over different ways. How can we draw? How can we capture the information draw? We'll put it in the ER diagram or diagram. Okay, so far so good, hopefully. Maybe someone say you didn't say anything. Yeah. Okay, so assume that we have this problem. If I ask you to develop an application for the undergraduate, you say administrator, okay? And required from here to collect information about the student, who takes which class, and some, the class rosters, and you say transcripts, some information, academic information. So how do you proceed? We say how to proceed, just to try to figure out which role that you are playing here in this problem. So someone to hire you to build this application. So remember we talked about the database users before, yeah? We said you have multiple users. We have a naive user, the one that just, to what? Normal user. I'm not gonna say naive. When we say naive, this means you're doing nothing. There is one application, so use this application in order to access the data. Yeah? Sophisticated users was the one other users that interact with the database without writing programs. So in this case, they don't use, an application to access the data. They start to what? They log into the database, or the same thing that we're gonna do during the this semester when we try to log into the Postgres. Then you try to perform, let's just say, actually starting executing the query directly on the database without using the application. So start to send you a query, interact with the data without, anything in between you and the database. So there's no application we can use. Application programmers, the one that we're gonna play the role in this class, because someone gonna hire you in order to build an application which can be used by the naive user to access the database. And we have a database administrator, which has more, duty, yeah? Mainly database administrator can do the following: create a schema, decide what's the physical schema, how these are going to be laid out in the disk, specify the schema, the one that can modify the schema, the one can grant authorization, and also the one that can enforce integrity or specify the integrity constraint. So it looks like in our goal, in our role in this problem with someone hiring you, you're going to maybe two roles. You're going to play as an application programmer, and also you can play the database administrator at the same time, because maybe you can involve to get specified ads, how did it be laid out in the disk answer. Okay, so keep this one for a while, and let's take a look at the overview of the design process here. So when you start designing a database, okay, by the way, for the small application, sometimes you're going to see someone going to say, I didn't need anything to design the database because I'm familiar with exactly the system is supposed to do. And since the system may be required for me to have a small system, require maybe one or two tables, so it's easy to say, oh, it's easy to decide that it looks like we have maybe one or two tables. I put all my data here, then I build my application and done. Yes, that might have happened, might work for the small domain applications. Okay, it's easy to come up with the relation that you're looking for. It's easy to come up with what kind of attributes, what kind of relation between of them. Then it's easy for you in order to decide which constraint you're going to use. Yeah? How could you specify? How could you enforce them? But that's the case. And for example, it's difficult for the hard, real-world applications, because most of the cases, the applications I try to build is like highly complex. So in this case, the database designer, or the one that's going to start to design the database, must interact with the user application to collect many information. Okay, first of all, I want to, when someone hires you, which is the one that I give you in the class project description, I give you all the information that you need in order to build the system. So this is the kind of information that we want to collect. So when someone hires you, please, I want from you to build an application, design for database application for me. The first thing you're gonna do, you need to interact with this guy, to the user of the application, domain expert, to understand the needs of the application. What you wanted to do? I want to build application, do 1, 2, 3, 4. Okay, what kind of attributes you wanted to collect? For example, we prefer to use or define, or say, a flight number, for example. We need to have, let's say, the flight destination. We need to have the air or the plane, for example, whatever specific number, unique number. So you collect what kind of information that you're looking for. Then after that, you need to collect whatever you have. Then you represent them in high-level fashion that can be understood by any users, and also either by the user or by the expert. So you come up with like a sketch. You can say, oh, it looks like my system, something like this. Here, that one of the relation tables, some diagram, okay, something like this. So you can discuss this one with the users. So this is the system and based on understanding, that's what we're looking for. What do you think? So it's easy for the user to say, oh no, maybe we need to add some extra piece of information. We didn't need this kind. So kind of interaction, collect information. Then after that, once you're done, we agree with this one, now we're going to translate the requirement, whatever you have, into the our level so in this case, you start implementing this one. You create your schema, then after that, database, then start to establish your application. Now done, the user don't know going to be interfere. Actually, they're going to interfere because maybe sometimes they does or they don't want. I mean, they don't like, for example, the way that you build your interface, etc. But I mean for the design itself. Okay. So the question here: why do we need it? I can summarize why do we need it as the following. We need to agree on the structure of the database before deciding on the particular implementation. You cannot jump right now, open your computer, then start coding. No, wait. You need to figure out what you're planning to do, right? Okay? What the structure of the database, how the database looks like, what kind of relations, etc. So we need to consider the following issues. What entities to model? All the objects. In other words, what kind of relation do we have might be here? Okay, how these relations can be related to each other. For example, you specify that it looks like in my data, assume that university database. You can say there's an instructor, there's also a student, there's a course, etc. Okay, those are the entities that you have. Okay, what the interaction, how they relate to each other. So when you say how they relate to each other, you need to represent this one in the, let's say, graphical, or let's say in the high level fashion that can be understood by anyone that accesses. Take a look at this, the design, okay? Then after that, whether you have any constraints or not in this domain. And after that, you need to figure out or find out a way of how could you achieve good design. Because this design from another design, some designs are going to be bad, others are going to be good, okay? So mainly in order to do this one, the easy way we're going to discuss what's called the ER diagram. Actually, we do have many design phases, so I will go over these ones fast. Then after that, I'm going to summarize them. So the initial phase for the design, you have to do what? You need to collect the needs of the prospective database user. The one that hire you to build the system, you need to talk with them in order to collect information. What are their expectation, what their kind of attributes that you're looking for. At the same time, what kind of transaction that you're going to perform. For example, you want to build a bank system that contains this, does kind of interaction between the users, what they're looking for, the security, and so you have to collect all these information. By the way, we say the security, I mean the security of the data, secure the data, etc., not the security to hire the guards, etc., okay? So anyway, yeah, by the way, bear with me. So I'm gonna talk too much at least for the maybe 10 minutes more. Then after that, we're gonna try to summarize, do something interesting, okay? But I need to cover this one. I need to speak or talk about, give you an idea what's going on. Okay, so you get the outcome of this phase is gonna be the specification, user requirement they're looking for, the user expert. Then the second phase, you try to come up with a choosing data model in order to intercept whatever you collect and put it in one, abstract view. Okay, so in this case, we're going to use the entity relationship model, which is the way that you use in order to represent, the conceptual design, which is the nice way in order to come up with, the way that help you in order to come up with, or the high level description of the database. Okay. So in this case, my folks as the designer just describing the data and their relationship. So you see that we have one data. I'm going to show you how can you draw this one. There is, for example, instructor, and this is information about the student, and for example, the courses. Then after that, what the relationship between them, whether there is any relationship between all of them or not at all. So you collect these information. So it's just the main goal here in this case. Then after that, after you're done from this one, you need to go over the final phase. From this case, you're going to perform, let's say, from the abstract data model, now we started the implementation. So now first I need to have a logical design. So in logical design, you need to define the schema. So now we're going to say instructor that have, for example, those attributes, and those attributes have the following data types. Okay? Starting is doing that. Then after that, we're going to do the physical design where you decide how the data is going to be laid out, the data on the disk. Now they're going to be the database administrator. The one is going to create a database. The one is going to have assigned, for example, grant the permission who can access what, and etc. And how is it going to be stored in the disk. Okay? So let's summarize this one. Okay, the design process as following. Let's do this one. The first one, requirement analysis. So in this case, technical and non-technical people are involved in this stage or this phase. User perform, let's say, interview, domain expert to talk with these people. You try to collect what's going to be stored, what kind of information you're going to collect here, how it's going to be used. For example, usually I use this attribute in order to help me in order to decide or do what. So you need to understand actually what the real world application or people doing in the real world, yeah, with these kind of data. Then after that, what are, for example, we going to do with this data? What I'm planning to do? For example, we expect that we have per month or quarterly basis, we're going to have like a report that contains this kind of information. So all these are going to be collected. And also, who should access the data? For example, everyone. No, only authorized users. So you have starting collect data because now you think you need to have like kind of user authentication in order to make sure not everyone can access what. Okay? So the second one, conceptual, design, which is going to high level ER, or entity relationships. Okay? Model that we're going to use here. Here, come up with a high level description of the database. In the high level, not deeper, okay? I'm going to show you how can you do that. Then it's going to be, by the way, we say high level, that is sufficiently precise that technical people can understand, at the same time, not so precise that non-technical people cannot participate. So people with the database fields, so they can understand what's going on. So it looks like not random, like high-level description of the data. The description that follows set of rules. So anyone can understand this one. It looks like, by the way, you build the UML for your class project. Whatever, Java class, etc. You put all the class together and you have some the relation between the class, every single class, interfaces, etc. So anyone in the system or the domain expert can understand this one. In our case, at the same time, even the non-technical or the normal user, the one that hire you or the user who use that application, and also the one the domain expert hire you to build this application, is going to understand what's going on because it's going to participate. Because you're going to show to them, they say, this is the design that I locked this. Maybe you're going to say, oh, you missed the information about the social security number. We need it. Oh, or maybe we don't need the social, we don't have this kind of entity, some kind of format. So it's going to help you in order to enhance your design. Then after that, now we come up with the implementation. When we say implementation, I will put everything together here as implementation. Because in this case, you need to have like the logical design, which you can come up with the table of relations that we have. The schema refinement is something maybe we can actually do even before that. So we talk about the schema refinement. Actually, we do this one after the logical design. This case, we call the normalization. I'm going to cover this one after we finish the SQL query. Because in most of the cases, maybe you will never use this normalization technique in your life when you work with data. Rarely people use this one. If you follow the exact steps that we're going to cover this class, so definitely in most case scenario, you're going to end up with a great design. Okay, with good design. So here, maybe 5, maybe 2% from the cases that you need to check. You take a look at the schema. Maybe take a look. Maybe my design has some redundancy or bad thing. You can identify bad design or bad component to your design. Then after that, you try to refine to make it better or come up to better design. Okay, we call this one normalization. Then after that, physical design, create indexes and etc. How to store the desk. Then after that, maybe add security design. Maybe have some access control, which we're gonna cover later when we talk about the grant, etc. Who can access what of the data? Whether every single one can access the data, or maybe a sub of the user can access the data. You're still awake, by the way. Just make sure that you don't fall asleep. Oh, you're sleeping then. Thank you. So back to the problem here. If I said devolve the application now, what if I said maintain an application? That means that's going to happen to you a lot, okay? When you graduate from here as a software engineering, etc., maybe you're not going to build the system from the scratch. No, maybe you're going to give you put you in the group that work on the project, and the project already there. They ask you to maintain the application so that it may keep supporting. If there's a bug, you need to fix, etc. So in this case, you need to understand how the application works, yeah, from the scratch. So assume that we get back to the same problem that we have. You try to build the undergraduate administrative system that contains information students, classes, and etc. Okay. If you are new database administrator, okay, what would you rather inherit? Something like this, the schema, or something like this? Of course, you need this one, definitely. But at the beginning, you need to understand that I need to have an idea what's going on in the high level for the system. So I know student takes courses and so you can understand what's going on in the high level. Then after that, of course, you have to go deeper. So in this case, you have to go deeper. You need to check how the student looks like on the side of the table, how the course going to be looks like on the side, and the takes, etc. But at a high level, we prefer to have something here compared to this one. And I give you why in this case. Assume that you're going to build the health insurance company system or hire you to build the system in order to catch and say fraud. Okay. So the schema, we did have a patient, visit doctors, medicines, and doctor perform operations. So we have a lot of entities involved, and also we have too many attributes and transactions going to be catching the system. Good. So if you think about how many tables we end up, we have this table for the schema, 10, 20, 30. It's not 10 tables. It's not 20 tables. It's 30. If there are 10, 20, it's easy to say, oh, yeah, it's okay. Give me the schema. It's easy to understand what's going on. But actually, in this case, this one going to be spans, let's say, around 120 pages. Oh my gosh, 120 pages just in order to understand the schema of the system. It's painful, yeah? So in this case, we believe that if we inherit the ER diagram, okay, what's going to be excellent documentation tool and give me idea what's going on. Once I understand the sense of high level, it looks like it give me like UML that describe my project in Java or any object-oriented program. Once you understand what's going on, now we're going to say pinpoint to the place that, oh, it looks like we have a problem because when someone tried to log into the system or update this piece of information, something happened. So I know that I need to check this relation or this relation. For example, a student takes a course, we do have a problem, maybe not all the courses can be registered in the system. So I know that I need to focus on this area. So now you can go deeper, take a look at the documentation of the schema, check what's going on with the student, what's going on in the takes, and what's exactly course looks like. Okay, so again, when design approach, we divide this one into two parts. The entity relationship model, which is the one that we're going to cover today in this chapter. Then later we're going to normalize it, a theory that we can check to formalize what do you mean by the design is bad, how could you fix it? Okay, so now when you work with this one, I'm not going to go with more details here. So the entity relationship model, ER model, is what? Is a graphical approach to database design. It's a high-level data model that defines data elements in general, and their relationship for specific, or let's say software system in general. An ER model is used to represent real-world objects. And because that the ER model is independent on any database management system, so regardless whatever database management system, it's not going to be changed. It's going to be the same model, yeah? I mean, talk about the ER model. We do have the ER model can be represented diagrammatically by an entity relationship diagram. So we have ER model, okay, with the abstract high level that show you how to design my data, okay, or high level data model that defines the data elements and their relations. How can you represent them? I'm going to represent them using the ER diagram, which is the one that we cover, okay. So in this case, it's going to express the overall structure of the database graphically. The way. Okay? Finally. Now let's start. What do you mean the AR model? So I'm going to take a look here and show you what is the component that we need to say. We need to know what do you mean by the entity. What do you mean the relationships? And what do you mean by the attributes? This is the basic. Then advanced later, we're going to take a look specialization, generalization, aggregation, which is going to be an advanced, which rarely used. We don't use them a lot or too much. Okay, so those are the basic components here. So the ER model is, as you mentioned, is what? Is the visual syntax of the database design, okay? Which is precise enough, as you mentioned, for the technical points, but abstracted enough for non-technical people. And we're gonna be, somehow it's gonna be okay. I mean, later it's gonna be Hopefully you can understand this one. Let me jump to one thing then after that. This is the ER model that we try to build, something like this. So that you see that if you take a look at this one, this is about the university database. You see that, you can see, okay, this is we have a department, we have instructor, we have a student, and here it looks like we have the relationship between each of them. Something like this, okay? That's what you're planning to do. And this is the phase one. So now we imagine, and you know exactly what we need to do. What do you mean by the ER diagram, right? So we're gonna show you how can we build, how can we collect, we have some information, then starting building my ER diagram something looks like this. Okay, so I need to go back to the slide. I jumped to the slide 69. So back to the slide 22. Okay, so in the ER model, of course, it's developed by the Peter Chen in 1970. I hate the numbers. 1970 something 6, I guess. Okay. So anyway, it's I don't need to go with more details here, so we know what's going on. It contains, the following components. The first one, entity. Entity is what? Entity is a thing or an object in the enterprise that is distinguishable from other objects described by a set of attributes. For example, student is an entity. Person is an entity. Instructor is an entity. Course is an entity. Okay, everything is an entity. I'm gonna elaborate more, but keep this in your mind. So we have like entities, which is gonna be things or objects, okay, which described by a set of attributes. Okay, attributes might be identifiers. For example, it has the keys and non-key attributes. Some of them are gonna allow us in order to define the primary key and other key attributes. That's gonna be non-key attributes. Since we have an entity, different things, I need to have find out the relationship between these entities. So in this case, I'm going to talk about the association among several entities. Okay. So here it's used its own ER diagram to express the structure of the model here. So the ER diagrams are used to sketch out the design of database. Okay. We have a design database. I'm going to do this one using ER model. Okay, in order to build this one, it will come up with a way that how can we sketch, represent the ER model. I'm going to use the ER diagram, and we have many tools. You can use UML class in order to represent the ER diagram, or maybe use many online available free whatever resource. Okay, good. Now, please, if you sleep now, you need to wake up. So, what's the entity? We said the entity can be a thing or object in the real world that's distinguishable from surrounding environment. What does that mean here? Anything. Okay? It might be person, it might be place, it might be event, it might be object, it might be constant in the real world that we plan to model in the database. This is the most important thing. Okay? It might be a physical object or an abstraction. What does that mean in this case? An entity might be concrete, something can you touch, a person, a book, okay, or abstract, like a holiday, for example, okay? So an entity, as you mentioned, person, easy to say it's person, course, instructor. So each person in the university is an entity, okay? We do have an entity set. What's the entity set? When we said that entity might be a person, okay, or entity, it might be, let's say, a student. Okay, assume that we have entity student. An entity instance is a particular student, one of you guys. How can you say this entity? So I need to define, it's going to be described or defined by a set of attributes. So the entity student, it might be contains the following attributes: student ID, student name, the student, for example, eye color, so whatever kind of attributes that it gonna, describe that entity. So again, we have entity, might be anything, an object, anything we need to model in the database. Okay, object, event, place, person, whatever. Okay, an entity instance is a particular student, so a particular entity, a specific one. So how can you tell? So it looks like you have a set of attributes as I mentioned, and for these attributes, exactly, flight can be entity too. Anything, but an entity. An instance of a flight is a good example. That means you have a specific flight or particular flight. So when you define an entity, you have to specify or define this one entity based on the set of attributes. That's why I would say student, in order to specify, how can you define a student entity? That's anyone that, for example, has student ID, student name, GPA, and etc. First name, last name, etc. What kind of information? Okay? We can say, for example, customer is an entity. Yes. A particular customer, that means specific customer. Okay? Employee is as an entity too. A particular employee, we call this one an entity instance. So a specific one. Okay? An entity then has a set of properties, a set of attributes. And the value of these sum of attributes must be uniquely identify an entity. So it looks like for, let's say, a student, we said might we have a student ID, name, what else? GPA. That's what we want, for example. Some of them, this entity, or some of these attributes, are going to be uniquely identify any entity within this entity set. Because in the entity set, or instance, sorry, we do have many students. So how can you distinguish between student A and B? Usually, distinguish between the say use student ID with a unique identifier for us. It might be more than one attribute with going to specify or uniquely identify an entity. Clear? If we understand this one, then we don't have a problem. The rest just to try to collect more information, try to figure out what's the relationship between the entities and the system. Clear? So the abstract, I will say concrete might be person, might be park. Abstract might be course. Okay? A flight reservation. All of them are going to be abstract. Okay? So I do have an entity with an object or anything we try to model. We do have an entity instance with like a particular entity. For example, if entity of a person, a specific or particular person. Student, a particular student. So what we define here as something called an entity set. Entity set is what? Is a collection of entities of the same type is called an entity set. For example, we do have how many students right now? We have, for example, 60 students or 5 students or 100 students. For every single student, there's a student, I'm going to say an entity instance, all right? All these entity instances is going to go on, is going to form an entity set, and we call this entity set student. So it looks like we can say we have a relation student, and the relation student going to contains number of students. Make sense to you here? Great. The set that must be well defined. What does that mean here? When you say the set of all persons, the set of all courses offered, the set of all flights, the set of all instructors, the set of all students, that is called entity set. Okay? So we can, for example, the set of all people that are instructors in a specific given university can define an entity set called instructor. Flight, all the flights that we have, there will be an entity called flight. Okay? Employee, you can create an entity set employee where it contains all the set of employees in there, whatever company that you have. Student, we have an entity set called student, which might represent the set of all the students in the university. So as you can still, we start with the entity. Then after that, we define entity and entity type, by the way, the same meaning. Then after that, we define entity instance with this particular entity or particular student, specific one. I'm talking about you, or you, or you. Okay? Then after that, we talk about the entity set with a collection set of all these entities at the same time. Of course, when you say, how can you make just one the collection set of entities at the same time? Must share the same properties or attributes. So in this case, I cannot say this is student, entity set student, that contains the student and instructor. No, Why? Because the student instructor don't have the same set of attributes. They don't share the same properties. So that's why I say now we might be have an entity set student and might be have another entity set called instructor. One thing I need to add here, the entity set can intersect. What does that mean here? This means doesn't need to be disjoint. So sometimes you have one, it might, let's say do this one, employee, which contains all the information about the employee in bank. Okay, this is our assumption. And we have a customer, which contains all the information, or the set of, let's say, all customer for this bank, on this bank. Okay, we might have an employee or person X. This guy might belongs to this entity set, right? Because he's an employee, and this guy might be customer because he has an account under this in this bank, right? So that's why you said it can be intersect. Of course, when you have instance with the employee, it's gonna have the same number of, let's say, a set of attributes associated with this one. When it gonna be an instance with the customer, in this case, you're gonna have maybe a set of properties or attributes that declare or define a customer. All right, person. Maybe you have like entity set called person, which contains this list of a set of all persons in the university or in the world. Let's do this one university, okay? Don't expand a lot. Then after that, I can come up with something else. Maybe have a student. A student can be what? So Y, it might be student, and the same kind might be a person. Yes, he's a person. Then at the same time, he or she a person. Then at the same time, he or she maybe a student. The same thing for the instructor. Okay, make sense? If we understand this one, then the rest is gonna be too easy. Okay, this is just, I'm not gonna say the confusing part. This is the way that's not 100% clear, but hopefully right now it will be clear. So now we can take a look at your class project, the description, and starting identify the entity set that you have. Okay? I will say okay to myself. Okay, so the entity set schema, what does that mean here? The entity set schema is the description of the entity set. We said the entity set is like a set or collection of what? Of the entities of the same type, okay, that share the same set of attributes, right? No. Cannot have a different, multiple entity as a different types. No, we can't. For example, you cannot say an entity set a student, which contains a student and an instructor. No, we said must share the same set of attributes. Must be from the same type. This is the meaning here. So if you said, just to give you an example, assume that you have a relation or a table that contains information about the student, and you have another table that contains information about the instructor. So we don't have a table that contains the student and instructor, or do we call this one a student, right? It's clear. So I already answered your question, right? Good. So what's the schema? The schema is just to tell me the description of the entity set. We said the entity set have a set of attributes. So how could you describe these set of attributes? The simple thing you're gonna say here, the schema is what? The entity set schema. You have to tell me what the entity identifier or the name of the entity set. For example, student. Then after that, you're gonna list the attributes. For example, you have an entity set student. When you have a student, and here we're gonna list all the attributes that we believe that we have in the entity set. So here, if you take a look here, an entity is called a student, okay? An entity is gonna be student, okay? An entity type is gonna be type with the student, okay? That has the following value for the following attributes. Student instance or entity instance in this case, we have a student one, for example, ID 1, a name Alice, blah, 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 blah. And you have a student 2 with another instance, another ID, Bob, and etc. Okay? Good. The entity maybe is represented by a set of attributes. We must have a set of attributes. Otherwise, I cannot specify the membership. I cannot decide where, how can we tell whether this instance belongs to this entity set or not. Okay? So just speaking, when you talk about the attributes is going to have like, we need to talk about the domain of the attribute. The domain of the attribute that is defined as the following: the set of permanent values, the value that allowed to have of this domain. What's the valid value for this domain? For example, the for number, any digits that contain any 10 digits, for example. Of course, not all of zeros, not all of one, not two, and etc. But that's the format of the telephone number. For the social security number, the same thing is you have how many numbers do you have in social security? How many digits do you have? You have 4, 7, 8, 9 digits, I guess, yeah? So must be 9 digits, and etc. That's what you have the social security number between all zeros and all 999. Of course, there's some of them invalid, so remove these numbers, invalid social security number. That's the meaning here of the domain. Right now, we talk about the attributes here. For every entity is described by a set of attributes and data value, of course, because when you talk about the instance, you said, for example, student ID, name, and GPA. When you have a entity instance, I need to specify what the name, what's the student ID, and specify value for what attribute the GPA in order to have this name, or this is the instance of the attribute, or entity instance. Right now, we just focus in the attributes that are simple. That means it's not composite, it's not multi-valid attribute, cannot be divided into multiples. In the few slides, we're gonna go expand this one, then talk about more details about these kind of attributes. Some are attributes or entities gonna define, let's say, the primary key, because I need to, in order, how can you distinguish between student and another student? So we need to find something, a set of attributes, either it can be one or more attributes, which allow me in order to distinguish between one entity and other entity within the same entity set. So how could you distinguish between you guys, the student IDs? I mean, student, of course, I answer myself. It will be by the student ID, right? I'm just focusing on your student ID in order to tell, yes, this is the student that, this student 1 and that student 2. Of course, someone can say, can you use the first name and last name? Yes, but we cannot guarantee that every single student might have, I mean, we have a unique value for based on the student name and the first and last name. Okay, that's why we're going to use, the student ID in order to distinguish, uniquely identify any entity within the entity set in general. Okay. Database in general, by the way, contains or includes the same collection entity set in general. So in university, talk about the high level, university database has a collection entity sets. What kind of entity set we have? Instructor, student, course, and etc. All of them we call this one entity set. Okay? Which contains any number of entities of the same type for every single entity set, of course. Okay? Now the fun starts now. We're done from this, now let's have fun. This is an interesting part here. So now I know this is my entity set. I define my entity set. I wrote this one, for example, flight number, and etc. some information. Then I need to see how can we represent them. So we take a look at how to this one represent entity sets in the ER diagram. Then after that, we see what the relationships and attributes, etc. So the simple thing, an entity set is represented in the ER diagrams by a rectangle. So you're going to use a rectangle in this case, okay? Which is divided into two parts. We have one part at the top with the text shaded blue, which contains the name of the entity set here, okay? And the second part of the rectangle is going to contain what? The name of the attributes in the entity set. You just list the name of attributes. So for example, I do have the entity set called instructor, which has instructor ID, name, and salary. This is how can you represent them. There is instructor, the name, and here specify or list out the list of attributes. Okay, the next one, student. Okay, and those are the list of, you say, attributes that for this entity set. Right? Okay, the only thing you need to add here, if you have a primary key And you know what the small subset of attributes in the entity set that allow us in order to uniquely identify any entity within the entity set. So in this case, for it's enough to have only one attribute with the ID. That's why I'm gonna do what? Underline the attributes in order to indicate this attribute is a primary key. If I assume that we have more than attributes of primary key, so I'm going to underline both of them. Okay? That's one way in order to represent the entity set in general. There's another way, so I'm going to give you both of them. Okay? The other one, we're going to use the following here. So an entity set is represented by, in the layout diagram, by a rectangle. There is no two parts, only a rectangle. So for example, I'm going to represent the say instructor. And I say here, instructor. Okay, then after that, an attribute is represented in this case by an oval with the name of the attribute inside. So here we have the ID, or name, and salary. Okay, then after that, a line is going to connect this attribute, each attribute over to the rectangle for the entity set is described. So this one here, this one here, this one here, and ID I'm going to do underline because this is the primary key, right? So either this or this are fine. So now we have two different ways in order to represent your entity in your phase one or the class project. Either use this one or use this one. Either is going to be fine. Clear? Then we're going to continue doing this one for every single entity set that you have in the system. Questions? Okay. So it looks like everyone unhappy, as usual. So let's take a look at the relationship set. What does that mean in this case? Remember, you cannot say this is the entity, I'm done. No, you have now tell me, now we have like separate component here. So we need to find out what the relationship between each entity sets that we have. Two entity sets, maybe 2, 3, 4. They have somehow must be connected. Otherwise, I'm not going to leave this one here. So that's what we call the relationship set. So in this case, entities are often linked by an association or relationships, okay, which are connection or intersection, okay, or sorry, an interaction, okay, between the entity entities. For example, when you have a student and you have a class, so what's the relationship between the student and the class? Student is going to enroll in the class. We have a student and we have an instructor. What's the relationship between student and instructor besides the student hates the instructor? Advice. Okay, take a class with or advise. So that's what kind of relation we need to figure out a way how can we specify or find out this relationships. Okay, so in this case, a relationship set defined as a collection of relationship of that type. So let's do this one at a time here. We said the relationship is defined as association among several entity instances. So in this case, I'm going to take a look to the student, for example, and advisor, I'll say instructor. And assume that we're going to see, take a look just to entity set, entity, let's say instance in this case. We have a specific student, student 1, student 2, and we have instructor 1, instructor 2. And see what the relationship between this entity set, I'm keeping the entity set, and between the entity instance for the student with the entity instance of the instructor. For example, this student is going to have, for example, advised by this instructor. This student is going to be advised by this instructor. Or this student, or those students, C1, 3, advised, for example, by instructor 1, etc. So that's the relationship. So the relationship is going to be what? Is an association among several entity instances. That's what we did. So here in this case, this relationships, and in this case, specify that Einstein, this guy, because they have specific an instance, an instructor, and they'll be advising this specific student. Okay? So what's the relationship set in this case? Of the same type. So we do take a look all the relationship between what? Between the entity instances students with the entity instance instructors. Since I'm going to try to summarize, try to specify, try to represent the advising relationship, right? And I call this one at the same time, all of them, we call this one the relationship set. The same thing that we did with the entity. We define entity like we have a set entity that contains a number of entity instances, right? All of them with the same type, we can define an entity set, right? Now we have a relationship. Relationship that is an association between several entity instances that belongs, might be the same or different, let's say, entity set. Right now, let's assume that for the different entity set. We do have a special case that might be for the same, okay? Then after that, we do have a many relationship instance here. All of them from the same type that capture the same relationship is called the relationship set. Clear? Okay. So let's assume this one, generalize this relationship set. Is just to give you like the mathematical relation among more than two or more entities. Okay, we have a special case, might be the same entity set, but we're gonna see this one later. Okay, so each taken from the entity set. In order to define or to specify that, you can say, for example, assume that we have entity set 1 and entity set 2, and here we have a relationship R between of them. So we have one instance, the E, it belongs to the E1, and we have E2, small E2 is what another entity instance that belongs to the entity set 2. And in this relation, it's going to be E1 and E2. This is the instance going to be stored within this relation. Okay? So the association, between the entity set is referred as the participation. So in this case, I can say the E1 entity set is participate in the relationship R. I would say, yeah, E1 and E2 is better to say both of them are participate in the relationship R. So that means we have a set of entity instance from the entity set E1, and it's going to be somehow associated with a set or number of entity instance that belongs to the entity set E2. Make sense? And this is an example. So now we have an instructor, a student, and just we have a connected to say this instance is gonna be with this instance. And this instance, for example, instructor is gonna advise maybe two students, and etc. Good? How can you represent the relationship set? Oh yeah, in order to represent this one, so generally speaking, we're gonna use a diamond in the AR diagram. So here we have an instructor, we have a student. If you take a look, you saw something like this diamond. So you know that this is the relationship set. So here, student and instructor participate in the advisor relationship. Make sense? Let me give you an example. So it might be we have like a company here, and we do have a product. There's some information here, some information. Okay? And I assume might be there's a relationship called makes. So here you can say we have a company makes a product. Can I do this one? Yeah. Or we have a student here, and we have course. And what's the relation between them? Takes. Student takes course. That's the relation. Okay, that means in this case we have instance, sub-instance to say from the entity set student, in this case student 1, student 2, student 3, that maybe takes course 1, course 2, course 3. They have to say participate in this relationship or associated with those relationships. Generally speaking, like rule of thumb here, we use nouns in order to specify the entity sets. For say, instructor, student, applied, company, product, etc. And we, generally speaking, we use the verbs in order to specify or in order to give names to the relationship. Because, for example, student takes course. Instructor advises student. So you see that the names of the entity sets are going to be like nouns, and most of the case, the names of the relationships are going to be verbs. So here maybe you can say advising, something like this if you want, or advice. Okay? Sometimes here, for the relationship set, maybe we need to add like an attribute, extra attribute, in order to specify, for example, for the advisor, when that advising happened or start date for the advising. So in this case, can I put this information with the instructor? No, because not every single instructor is gonna have advise the student. Can I put this one in the student? No, because we don't can. It's not. I mean, common attribute to student gonna be date when start has an advice. But it makes sense to put this one here in the relationship sets. We call this one descriptive attributes. Okay. So again, a relationship as a relationship that may also have attributes, and we call these attributes descriptive attributes. Okay. For example, we have a customer account, and you have a customer and an account, and you need to log in information about this account. Maybe you're gonna define relationship set called login or customer account. Or is it gonna say when that the customer has been logged into the system, last time logged into the system, date, for example, or grade. So we have many options here to do that. So in this case, we have an instructor, we have a student, this relationship set. Now I need to specify the descriptive attributes. So you see that we have a set of rules you have to follow. So anyone take a look, work with the database. If you saw something like this, say, oh, this is instructor entity set, this is a student entity set, this is, oh yeah, this relationship set, oh, this is descriptive attributes. I know this one because based on the structure that you built here. So it's not randomly just put stuff like this or draw whatever. Joe and you say this makes sense, or this anyone can understand. So anyway, so the attributes of the relationship set is going to be represented in the ER diagram by what? By undivided rectangle. So in this case, the rectangle is undivided. I'm not going to divide this one into two parts. Okay? At the same time, I need to do what? I need to link this one to the diamond that's representing the relationship set using what? Dashed line. That's usually what we're doing here. Okay? You follow me? Great. So let's take a look to the role that we have. So when you take a look here, let's go back here. So the instructor and the student, when we have an instance of this entity set, it's going to participate, or this entity set is going to participate in this relationship using which role? As an instructor. So there is no need to say, this is an instructor. It's going to participate. This entity set is going to play an instructor role in this relationship set. And here is the clear, since we have a student, I'm going to say, and the ID or the entity set or entity instance of this entity set is going to participate in this relationship using what? As a role of a student. So there is no need in order to specify the role. All of this, what this play or entity set is going to be play here. Okay? So generally speaking, the function that an entity is going to be placed in the relationships is called its role within this relationship set. Normally, as you mentioned here, most of the case is going to be explicit and not specified. So there is no need to specify if it's clear. But sometimes it's not clear. Sometimes, especially when you try to, remember I said the relationship, it might be between two or more entities, and you have said we have one special case, it might be with the same entity set. Okay, so let me give you an example here. Assume that we have employee, okay, and this employee is gonna have what? Let's say, I want to capture the following relationship. We have one employee or a set of employee, they have a manager or managed by a specific employee or one employee. How can you capture this relationship? So in this case, if you try to do this one, someone is gonna say maybe something like this, okay? So you have employee here, and here I'm gonna say employee again. Then I'm going to copy the same one, employee ID, employee name, and address. This relationship will be something like this, yeah? So in this case, we have employee ID here, is works as employee, and this one employee ID is gonna be work as a manager, right? This is the role that this entity is gonna play in this case. Because we have like number of employees, and must have a manager, right? How can I capture this one? We're not gonna do this one like this. We're gonna use what's called the relationship set recursive, because I'm gonna take the same relationship is going to be, the relationship is going to capture the relationship between the same entity set. But the entity set is going to play different roles. Okay? So in this case, I'm going to say, okay, we do have employee. Of course, the error is not correct. I'm going to show you later what do you mean by this one. Okay, anyway, we have, in this case, the entity set is going to play what here? Participate in this relationship as what? As employee ID. As employee. That's why I said worker. Okay? Then, this one is going to be, we have another entity or instance from the same entity set will participate in this relationship as a role of a manager. Because a manager and employee are what? A worker are what? Both of them are employee. They're going to have the same information, employee ID, name, and etc. But we need to specify those one, we capture the information. For example, employee ID, in this case, 1256, that must have the manager ID, which is going to be captured by the worker. Manager ID, employee, for example, 12. Something like this. So again, for example, the relationship works for could be ordered pairs of the employee entities. The first employee takes, the role of manager, for example, and the second will take the role of worker. Make sense to you? That's what you call a cursor. So in this case, you have to specify the exact role. You have to tell me what's the role of this entity to play in this case. Because if we go over this one, it looks like we have one instance or entity instance for the employee, and we have another entity instance of the employee. So we need to distinguish between them and say they're playing different role in this case. To make this one clear, take a look to the course and prerequisite. What we have, the course and prerequisite with another course, right? Both of them, they gotta come from the course relation. They gotta come from from the course entity set, right? Because both of them gotta be an entity instance, right? We have CS4 to 5, CS5 to 5. Both of them are courses, you see? But the CS4 to 5 is what? Is the prerequisite for the CS5 to 5. So in this case, I'm going to say the CS4 to 5 is going to play as the prerequisite ID, and the course CS5 to 5 is going to play as the course ID. Both of them came from this entity set. Make sense? Good. That's one thing here. So the other thing you need to think about, take a look here, what's the degree of the relationship here? The degree of the relationship set is defined as what? The number of entity sets it links participate in this relationship set. So right now we have a binary relationship. It looks like two entity sets are going to participate. Maybe you have a more, maybe you have a less. So we have, maybe you can, a relationship set, a relationship in this case. So that means in this case, the same thing as I showed you before. In this case, we call this one here between the employee, because this, how many entities set participate in this relationship set? It's only one entity set. So we call this one, relationship. Okay? The one that we have, for example, in this case, what's the degree of the relationship? What's the number of entities set it links here or participate in this one? We have here 1, 2, so exactly 2. So we call this one binary relationship. Okay. Then we have, might be the chance to have a ternary relationship and more. Okay. When you say ternary relationship, that means maybe you have more than two entities that's going to participate. It might be the case. Okay. So we talk about the ternary relationship. Oh, one example, another one. You can say we have a patient. Here, I can use a patient. Just an example, okay? Maybe you have a drug, okay? And this is a doctor. We call this one, and here maybe we have different relationships, okay? Prescription. So we can specify here doctor or the patient, or the doctor prescribe a drug to the patient. That's the way how can we try to, I don't know why this one not clear. Okay, so we can catch this kind of relationships. Or, as we show you in this example here, assume that in this case we do have like entity set project, entity set, instructor, and we have an entity set student. Okay, so assume that the entity set project is going to do what? Represents all the research project carried out in the university. And you have a list of all of the students here, and here are the list of the instructor. Okay, we assume that each project that we try to capture in the project guide, I need to find for every single project who the instructor that advise who student, or who's a student in this case. Yeah. So in other words, each student might be working the project, must have associated with the instructor, okay, who guides the student on the project. So this relationship that we try to capture here, for example, we need to just to focus on which instructor is guiding, let's say, which student on which project. That's the mean. So in this case, we have like ternary relationship. Maybe you have more, but most of the case we're gonna have like a binary relationship. Okay, good. So let's take a look at the attributes itself. So we're done from the entity set. We know how to come up with the entity set. We know how to represent this one. Then after that, we looked at the relationship set. We know how to define this one, how to identify, how can we represent it. Then we have a different like relationship, we say degree of the relationship. Now let's take a look at the attributes. This is the third component in the ER diagram. And we've said here we have different types of attributes. The first one, the symbol attribute. What do you mean the symbol? That attributes that only take atomic value. So in other words, cannot be divided into subparts or subcomponents. It's not composite. It's symbol. It's like salary, GPA, ID, and etc. Okay? The composite attribute on the other side is what? Is an attribute that can be decomposed into smaller elements. You can break it down. Okay, for example, it might be sometimes they give you like, I'm going to say attribute is going to be name. And the name is going to be first name, middle, let's say last name. So in this case, the attribute here, I have a problem here. We say, how can you represent this one? So that is called composite attribute, with attribute name, which can be decomposed into first name and the last name. Attribute might be address, which can be decomposed into what? Street number, house number, a house, and zip code, city, state, and etc. Yeah. Class sometimes, or phone. We can sometimes, if you said, I can classify this one the area code and the city code, etc. Or a class number, sometimes if you have CS, for example, 525, sometimes can be classified into what? CS 525. So the department and the code within department. That's one way, but most of the cases we treat this one as non-composite because we don't break it down. Unless the system that we try to build requires from you to decompose this one. Okay, clear the composite and the symbol attributes. Okay, so the single value and the multi-valued attribute. What do you mean by the single value? That's mean the value has only single value, only one. I don't have multiple values. Student ID, name, student ID, last name, yeah, last name, etc. We have one value. But sometimes we have what is called the multi-valued attributes. That means some attributes may have a multiple values for an entity instance. For example, student may have, for example, more than one email address, or maybe more than one phone number. So we have a multiple phone numbers, maybe 0, 1, 2, 3, 4, in the same instance. That's what I'm talking about. For example, student 1, phone number 1, 2, 3, 4, it's going to be multiple value, must be stored under one attribute. Of course, this is a problem with the relational algebra, relational data model, but now talking about the ER diagram almost. They told me, they said, we have the phone number of this attribute must be multi-valued. Student maybe have a 0 or more, or the user. So now we need to model this kind of information, okay? So because they taught me For example, the name is composite attributes, and also the address composite attributes. That can be broken down in a number of components. The, for example, phone number might be multi-value attribute, because for one specific, or for every single user, maybe have multiple values in this case, or multiple emails. Okay, that's another thing. Another thing we talk about is a derived attribute. Sometimes you want to do what? To include in your design an attribute whose value can be calculated when needed. So, for example, the best thing, assume that we have an attribute date of birth. Okay, you are going to store information about the date of birth. Then, assume that they wanted to have treated age as an attribute. They said, we want a date of birth and we want an age of the customer or the user also. So he said, okay, do you have a date of birth? So I can compute or derive the information about the age, right? So there is no need to put the age as a separate attribute. But in this case, I need to capture this information in my design. Then later when you compute, I need to find a way how to compute or derive this information. Clear? So attributes that are not to be stored, okay, but whose value are to be calculated or obtained from other source are called derived attributes. Clear? You know that I need just to double check, make sure that you're still, let's say, alive. Yeah. Thank you, Yuan. So, domain or value set, we talk about this one. For every single, this is a set of allowed value or private value for each attribute. And we can specify this one, for example, semester, spring, fall, summer, only 3 values, or as we give here, the 4 values. The course ID might be a set of all text, for example, string of the certain length. Must be 5, 6 characters, etc. Must be start with character, no letter, something like this. Okay? So just to back here. So this is the way how can you take a look at the composite attributes. Some composite attribute, their component might be another composite attribute. That's why it might appear as hierarchy. For example, composite attribute name and can be composed in the following. Okay, or decompose actually into the following: first name, middle name, last name. We call this one the component of the composite attribute. The composite attribute in this case can be decomposed into the following components, and sometimes some components can be decomposed further. It can be like another composite attribute. So in this case, the address can be street, city, state, postal code, zip code. Then the seat itself can be decomposed into what? Street number, street name, and say apartment number, etc. Okay. So the question here: how can we represent this one? Okay, I know the name might be middle name, first name, last name, and address is gonna have something like this. How can you represent it in the ER diagram? It can be represented as follows. And also, how can you represent, say, the multi-value attribute? And how can you represent, say, the derived attribute? So, if you wanted to represent the composite attribute, this is the way how to represent that. So you take a look to the ID name. This is the normal attribute. Remember this one entity set, right? The name of entity set is the first part, and the second part of the rectangle. I'm going to just write down, or list the set of attributes that we have, right? So we have the ID here, the name. Now I have a composite attribute. Remember, you have a name, first, middle, last. How can you capture this one and represent? You're gonna do this one. Write the composite attribute name first. Then after that, the next line, do like an indentation, maybe a few spaces. Then write the component of this composite attribute: the first name, middle name, last name. So anyone take a look and say, oh, it's clear, that name is a composite, and those are the components of this composite attribute. Now the same line, I have address. And address is gonna have what? Street, city, state, zip. And the street can be further decomposed into street number. So that's what they're gonna be for me. Here, indentation, your space. Then after that, another space to make sure that if you want to take a look here, say, oh, those are composite attributes. So we clear this one here. So you can see this has composite attributes. And this is another composite attribute. You see that we have 1, 2 composite attributes. Clear? How can you represent, the multi-values? Multi-value is going to be what? take the name of the attribute and put it between curly braces. So example, assume that we have emails. I can write email, multiple emails, or multiple phone number, and that's what you do. This is the multi-valid attribute. Okay, how can you represent the derived attribute? By the way, I have to represent it here, but you're going to see later when you convert this one to the corresponding ER model, the relational model. So we are not going to reserve, let's say, a separate attribute. We are going to calculate it to somehow write maybe algorithm or like function when the user requires from us to compute the age. I'm going to go to the date of birth and figure out the way how can we extract or derive the age. So the age is going to be whatever derived attribute is going to be written as a function. Name of attribute, for example, age, and here between two parentheses, just to indicate that this one is going to be computed. Questions? So we see that we're starting, we have descriptive. You can start right now, work with the class project, by the way. You have to finish this one, by the way. You have a week, I guess. I will check. If I didn't specify this one, I'm going to send you an email to make sure that we have to finish this one. So you have to start doing this one as soon as possible. It's easy. The only thing you need to read the description, figure out what kind of attributes into an entity set. Then after that, try to figure out a way, how could you represent them? Okay? Please, by the way, use a computer. You have to, don't use a pencil, paper and pencil, draw your diagram. No, you have to submit this one in, let's say, in printed format, okay? You have to type this. Draw some or using whatever software available online. There's many websites available online. You don't need even to download anything in order to allow you to write this one, or using even the Microsoft Word in order to do that. Any question about how can you represent the relational? I'm killing relational algebra. I don't know why I say this word. Anyway, how can you represent the ER component, entity set, relationship sets, and also the different attributes? Okay, so I will stop here and give you like 15 minutes. Okay, back 2:35. Okay. Okay, guys, welcome back. So now let's take a look. How can we enforce or specify the constraint or restriction on the relationships? Okay, so the ER enterprise schema may define certain constraints, specification, rules, or constraint on the to which the quantitative database must conform, must follow, must be satisfied. Okay. So mainly we do have two types of constraint of the relationship. The first one is called the mapping cardinality, and the second one is called participation constraints. Just gonna see what do you mean exactly one of them. One at a time, then after that see why we need them. Okay? So the first one is the mapping cardinality. What do you mean the mapping cardinality? Mapping cardinality is the binary relationship I'm talking here, is the number of entity instances to which another entity instance can map under that relationship set. For example, when you say we have a student can be advised by an instructor, how many advisors? How many instructors? Maybe one or two, or maybe many students, or advisor can advise how many students. Maybe we have some structure of database on the system that we try to build that specify, for example, each instructor can advise at most one student, and one student can advise at most by one instructor, something like this. So that's what we try to capture here. So again, it's the data constraints that specify how many entities an entity can be related to in the relationship set. Okay? Mainly it's going to work with the most useful going to be the describing the binary relationship sets. If we didn't do this one, that means it's going to be like open here, yeah? So in this case, we're going to take a look to say, assume that we have entity set A and entity set B, okay? And the R is going to be the relationship set between of them. So the mapping cardinality, we're going to find how many entity sets are going to be approximately this one, whether one or many or all of them, some of them, and etc. Can be summarized as follows: one-to-one, one-to-many, many-to-one, and many-to-many. So let's take a look one at a time. What do you mean one-to-one? So one-to-one here, that means here, the relationship set, if we take a look here, you assume that we have here A, okay, and here you have a B, and here the relationship set are between them. So I'm gonna say here, an entity in A, in this case, if you said one-to-one neighbor cardinality, an entity set of A in A, okay, it's gonna be what? Is associated with at most one entity instance in B. That's what I'm looking for, an entity instance, of course. And one entity instance of B, or in B, can you say is associated with at most one entity instance in A. So it's one-to-one, okay? So this means in this case, if we have like A and R, assume A is gonna be student, and B is gonna be instructor. I'm gonna use I and say S, okay, to simplify the process, okay? And R is gonna be advisor or advisor. So that means if the relationship from S to I, to student to instructor, is one-to-one, that means and one student can participate or can be related, can be associated with this, has a, can be advised actually here with at most one instructor. And one instructor can be advised at most one student. When you say at most, it might be 0, it might be 1. That's why we have some entity instance, it might be not participated in this entity set. There's not going to be mapping actually to any element in the state. So in this case, we don't have this case in this case for B here, or to C here, we don't have this situation. This is not acceptable. Because based on one, the entity set cannot participate in more than at most one entity set. Or entity instance, actually, not entity set. Make sense? So one-to-one in this case, yeah, one-to-one. So that's going to be, but maybe you cannot say at most that some of them, maybe the entity instance not going to be maybe to any entity instance in other relation. The other thing we need to think about is look at one-to-many. One-to-many is like, if you understand this one through this, it's going to be great. It's not hard here. One-to-many, that means still we have the relationship set R, okay, between A and B, okay, and I'm talking about from entity A to entity set B. The relationships are from A to B, okay, that's what I'm looking for. So that is many or one-to-many. We'll call this one one-to-many. What does that mean, one-to-many in this case? That means an entity instance, okay, in A can be associated with what? With many entity instance in B. When you say many, that be zero or more, any number. So that's why we did this one. We have A and B, one-to-many. That means one from here can be with many of the other sides. It can be with many entity sets, okay? At the same time, an entity instance, okay, in B is associated with at most one entity instance in A. So in this case, we didn't have this situation. This cannot be. That's the meaning of one-to-many. Clear? So this, if you take a look one-to-many, you can see why you have a many. So if you take a look at the many, here we have a many side, and we have one side. That's the meaning here. So one-to-many, again, one entity A can associate with any number of entities set in B. At the same time, an instance, or the entity instance B, cannot associate at most with one entity in A. With an entity instance with A, for example. Okay? So in this case, if we take a look at the relationship here, this will give you an example, maybe help us to understand here. Yeah, we have like relationship between mother to child to one, let's say, yeah, we have a mother here. We have a child, okay? And what's the relationship between mother and a child? It's going to be one-to-many. Why? Because the mother can have many children, but each child has only one birth mother. I should specify birth mother. So in this case, the mother can have many children here, but each child will have only one birth mother. So we call this one-to-many. From where? From mother to the child. If you look at this one, the other opposite side here, when you say one-to-many from A to B. But if you look at this one, what the relationship in this case from B to A, it's going to be many to one. So it depends on the direction that you look at the relationship set. So since we said the example, it's going to be one to many from A to B. That means if you look at that from B to A, it's going to be many to one. Why? Let's take a look. If in this same case, if we said I'm looking from B to A, if you take a look at B to A, that means many. That means if you take a look at many, which is going to be the next slide, but I'll try to summarize this one in the same one here. So an entity instance, you say, and B is associated with at most one entity instance in A. But each entity instance in A can be associated with many entity instances in B. So that means that's most here. That's the meaning here. If we take a look here, one here, yeah, this here is going to be something here. We said many to one, right? That's the meaning here. So from B to A is many to one. So it depends on which direction that you look at. Which direction, from A to B or B to A. Make sense? So that said, an entity, many to one in this case, an entity instance of B is going to be associated, in this case, I mean here, associated with at most one entity A. But an entity entity instance A can associate with any entity instance in B. So that means this is the many and this is the one. So let's take a look, many to one, but in this case from A to B. So it depends. Right now we're saying just from A to B, but I'll give you an example. If you look with the opposite direction, from B to A, it's going to be what? One to many. Okay? So what does that mean? Many to one, that means an entity instance in A can be associated at most one entity in B. At the same time, an entity instance in B can associate with, let's say, any number, with many, okay? Let's say any 0 or more. It might be 0, might be 1, might be 2, might be 3, with many entity instance in A. So that's why we have, this is the many side, because we have many side relation, and we have a 1. So that means many to one. For example, if you take a look at many to one, that means take a look at the child to birth mother relationship, but in other side. So we do have many to one from what? From the child to birth, mother, yeah? Because each child has at most one birth mother, but each birth mother can have many children. Clear? Generally speaking, as you mentioned, a many to one relationship is usually or actually the same as one to many, but viewed from the opposite side. So if you have, in this case, we said the relationships or the numeric cardinality here is many to one from A to B. That means if you take a look from B to A, it's going to be one to many. Okay, makes sense? I know you need a cup of coffee after today's class. So the other one is many to many. Oh, the map becoming many. So that means many to many is easy to formulate similar to the way that we did one to one. But here the difference is what? For an entity instance in A can associate with any number of entity instances in B, and an entity instance in B can be associated with any entity instance in A. Okay. So this is an example. Try to find one for the family, I guess, yeah, grandparent and to the grandchild. So in this case, we can say it's many to many, right? Relationship. Why? Because a grandparent can have many grandchild or children here. At the same time, a grandchild can have many grandparents. Yeah, from the father or from the mother and etc. You see that? So that's the many to many. So this is gonna just to help you to see or try to specify the constraint that we need to enforce here. Which in this case to do what here? Try to say, for example, then try to find a way to express the number of entities to which another entity can be associated via the relationship set. Or how many entity and set actually an entity can relate it to. Whether it's going to be one specific entity set or multiple. So it depends on what you're planning to do in our class project or in our project or in our system that you try to design. So let's give you an example. So it depends on the data. So see what kind of one-to-many or many-to-many. One. Assume that we have a student and we have like an instructor. We have a student here. And we have an instructor. And the relation is advisor. Okay, something like this. So if I assume that based on the data that we have, the student can be advised by only one instructor. Assume that this is the condition that we have. Or this is the constraint that we need to specify based on the data that we have. Just assumption, okay? Student can be advised only by one instructor. Instructor can advise several students. So in this case, what kind of relation here? You can think about it here. It looks like from one instructor to the student is one-to-many. Why? Because it said instructor here can advise several students. That's what I'm planning here. You see? An instructor can advise several students. A student can be advised only by one instructor. So in this case, we don't have this case. Right? So the relationship here is going to be one-to-many. Of course, from the instructor to the student, I'm looking for this point. I'm looking for the relationship from this point, or this direction, right? Make sense? If we said if the student has or can be advised by several instructors, so in this case, it's going to be changed a little bit. So it's not going to be any more something like this here. I don't know if you can do this one or not. No, I can't delete this one. I thought that I can delete specific area. Yeah, they need to update this blackboard, whiteboard, make it more efficient. So now let's say they have an instructor here, and we have a student, and we have an advisor. What we said here, the student can be advised, let's say the instructor can advise multiple students, any number, 0 or more. Yeah? At the same time, we said the student, I'm talking about the second part, can be advised by several instructors. So this is the way, how can you decide? So can be advised by several instructors, something like this, yeah? So in this case, we have a many-to-many here, many-to-many. You see that? So that's how you decide what's the mapping cardinality here constant. Okay? So the question here, okay, we understand the mapping cardinality. We say we know that exact, or we figure out a way how can you specify or how many entities, for example, instance and entity instance can be related to this relationship set. So what's next? How can you specify or how can showing this cardinality in my ER diagram? Actually, we have many ways. Okay, the goal for this slide is just to give you that we have almost 5 different ways, and we are going to adopt one of them. Okay, this is the one that we're going to use here in these slides. So the first one, single-headed arrow. If you have a one relation on the one side, and the man is going to be represented as no arrowhead. Okay. So let's take a look one at a time. What do you mean in this case here? So that's what we're going to do here. Assume that we have, I'm going to use the random number. Okay, assume relation A. Entity set A and B and R. Assume the relationship is going to be, let's say, what do you say? Say many-to-one. Let's assume that's going to be many-to-one from A, okay, from A to R. From A to B, right? So in this case, if you use this way notation in order to specify with the one is going to be single-headed arrow and the many is going to be no arrowhead. So in this case, I'm going to do something like this. So this is the many, it's going to be line, single line, okay? No head here. And this one is going to be arrowhead. Single headed arrow, actually. So in this case, you see that when you take a look, anyone take a look, see this one, you're going to say, oh, there's A, B, and the relationship between A and B is many-to-one. You got this one? If one-to-one, both of them one-to-one, let's say one-to-one. I will do this one-to-one, okay? That means in this case, this is going to be here, R, and it's going to be used to say single-headed arrow in this case. Clear? That's how can we use this one? Simple thing. If both of them many-to-many, so in this case, many-to-many is going to be how what? I just use a line with no arrowhead. So we have relation A, entity set A, sorry, and B, then R. This is how can you implement, or how can you represent this one? Just lines. Use this one and gonna say, okay, it's like many to many in this case. Clear? Let's take a look at another solution using the one is gonna be single-headed error, and the many is gonna be double-headed error. There's another way to represent that. I will just give you example from one to many, because in this case we can't do the rest. It's gonna be similar, okay? So this is, assume that we have one to many. When you talk from A to B, okay? So we have the entity set A and B here, and here the relationship set R. So one to many, one is gonna be what? Single-headed error, this is the one, right? And the double or many is gonna be double-headed error. So this one is two. If many to many, that means we're gonna have two double error here and two double error here. Okay? Clear? So the third way, you're gonna use like dot or big dot here. So for the one side, I'm gonna use no arrowhead, and for the many, I'm gonna use a big dot here. Okay, so that's weird. Let's see. Sometimes you're gonna see this one in many implementations. So you take a look at textbook, you're gonna have different implementation, different ways in order to perform that. So remember, the big dot is gonna be at the end of the many, okay, line. And for the one, I'm gonna do what? There's nothing at the end of the one line. Yeah. So see, assume that we have many to one from A to B. So we have here A, we have a B here, and the relation R here. Okay. And this is, I mean, the entity set that we have. We've said many to one, and many gonna have what? I'm gonna have a dot here. This is a dot. Just dot. Assume this is a big dot. Okay, and the one, nothing there. Many to many, so this means dot here or dot here. Clear? We have another thing. We're gonna see in many textbooks. They use the car, I mean feet. This is weird a little bit. Yeah. When they teach us one last time, one student said it's chicken feet. It's car. This is the name, I mean, actually. So in this case, you're gonna do what? For the one side or one line, you're gonna do no error, nothing there. For the many, you're gonna use a car feet as symbol to say this is the many here. Okay, so let me do this one here. So we have A and B. I'm gonna assume many to one from A to B. Okay, this is A, this is B, this is relation R. Okay, and we'll say many to one. That's reason the many on one side they do nothing, and the many end up with like this. So if you saw this one, you can say, oh, this is the many side. Many to many, that means here, and this means here. Okay. The other thing we can use is say a number. Just in the top we say one, but just one, and the many is going to be m or n. It depends whatever number that we have here. Okay. So in this case, it's going to be many to many or one. Let's say do one to many. So relation R here, and the relation is say A. In this case, yeah. Yeah, I need to revisit, I mean, the core feet because there's something I missed. So here it's going to be one to many. Sometimes use M or use N. It depends. It's like any number. Okay. One thing I missed for the core feet that I don't need to specify without diamond. I'm not going to specify the diamond that contains information about the relationship set. So for this one, revisit this one. Sorry, I missed this one. So relation A and the relation B. This is how to do perform this one. Assume there'll be many to many. So the many to many, that one you're going to do here. Many to many. And here just you need to write the relation in the top. So there is no diamond. It's not going to be part of the discussion that we have. Okay? Hopefully you followed me, okay? Questions? Sorry, guys. Yeah, my kids, it's hard to keep them quiet for the whole day. They start fighting. Anyway, so we did this one, and now we're gonna take a look at that. How about if we try to? That's what we did, by the way. So that's what we are gonna do in most of our class here. So we have one-to-one. We have arrowhead, okay, or directed line with specifying one, and undirected line is another name, or this is for one-to-many. You see that? Yeah, let's take a look. What do you mean the one-to-many here in this case? That means in this case, a student can be associated with at most one instructor. Okay, so an instructor that means can advise, you say, many students. You see this one? Instructor can advise many students. You see how to see the one here. And the student can be advised at most by one instructor. So here it can be one to many. And this, if you draw this diagram, we can tell what do we want to many to one, etc. And based on the description structure. Because this, from where you got this information, you got this one from the domain that you tried to build, or during the user interview, we deduce this information, or those are a set of constraints that we need to enforce it. In many to one, in this case, assume that the instructor may advise at most one student, but the student may have many advisors. I don't know, maybe someone is going to say, it does make sense, but just an example. Assume that we have this constraint. So advisor can advise what here? Can advise at most one student, but student can be advised by multiple or many instructors. Maybe it's not, doesn't capture what we know about the university here, but this is, I mean, it might be the case. It depends on the constraint that we try to formulate. Okay, so in this case, we have the many-side directed line and undirected line, and the say the one side we're going to use a directed line, or if you prefer to use say single-headed arrow. Okay. Okay, so then we do have the last one. It's going to be many to many, which in this case, the instructor can advise multiple students, and student can be advised by multiple instructors, or having many advisors. I believe this one, nice example to go over this one, let's say class, yeah, or let's say student, or student, let's say course, and here enroll. So student can enroll with any number of classes, yeah, and the class can enroll in many students can be enrolled in the same class or in the same class. So we have this case many to many. That's nice thing which capture, I mean, the university database that we have here. Okay, question. That's about to be cardinality. One to say how count to say the number of say entity an entity insert can associate with, or but let's say connect to or refer to within the relationship set. Here we're going to talk about the participation constraint. So in this case, what we're planning to do here, we're going to say whether every single member of this entity set is going to be participating in this relationship or not. For example, every single student must have, let's say, an advisor, or every instructor must be advised a student or a number of students. So that means everyone. Remember, so far, what we're doing here, what we did here, let me go back here a little bit. We have a note here. We said some elements, maybe in A and B, may not be mapped to any element. Some of them have not. But right now, I need to specify whether all the entity, for example, here in the A, all of them must be participate in this relationship. B, not all of them. So it depends, by the way, the constraint that we have and the information that you collect, so you can decide. Might be you have this case. The goal here, how can we capture this one? How can we represent that? So again, it's possible not all the members say, of an entity set participate in the relationship. So we do have two different participation. The first one, we call this one the total participation, and the second one, we call this one the partial participation. So if every member of an entity set participate in this relationship, this is referred to as a total participation of entity set in this relationship. Okay, so how can we denote that? How can we evidence this one? We denote this one using the double line. Okay, from the entity rectangle to the relationship set. For example, everything, assume that A every entity or every member or the entity instance in this entity set must participate in the relation R somehow, whatever. So in this case, I'm going to use two double lines. Okay, that means total participation. All of them must be. We don't have an entity set is not participating in this relationship set. Okay, so a single line, we're going to use this one in order to what? And we're going to say some members is like partial participation. Not every single entity in this entity set is going to be, or maybe, may participate in this relationship. Okay? So that's what we did. So take a look in this case. What does that mean here? That means every single student must have an advisor. That's the meaning here. So by doing this line here, I know this is many to many, by the way. We said one instructor may advise 0 more students, and said the student might advise by 0 more instructors. But in this case, we said what? Every single student must have an advisor. So in this case, I have used this one double line. Make sense? Here, not every instructor. What is the case here? You know that in IT, when they hire you as a new professor here, they're not gonna allow you to give you involved in advising until you spend 2 years. And the reason behind this one is that, okay, you need to get familiarize yourself with the system, the courses, etc. Then after 2 years, I think it's good enough for you, and you're prepared to start, advising the student during the, to select whatever course for. Okay? Which makes sense in this case. So student total, instructor will be partial. Is there any way to put the cardinality of participation together? Yes. We do have a nice way, which is the one you're going to see in the exam that I'm going to use a lot of the exam, okay? So in this case, in the ER diagram, okay, as I mentioned, that's what we're showing so far. We have a single line or double lines which showing, let's say, participation constraint for the relationship set. The relationship's cardinality using by 1 or m, that's what we did here. For example, 1 and m for n or m, whatever letter you're going to use for the many on the upper right line. That's what we did in one option that I show you to represent the data. The ER diagram provides us with an alternative representation, different way, another one that shows that both participation and cardinality constraint are going to be what? It's going to be shown in one notation. So in this case, I'm going to use the minimum and the maximum. I can specify with the minimum participation and the maximum. So what do you mean by the minimum cardinality? That means the minimum cardinality specifies what? As the number of entity instances that must participate in this relationship set instance or relationship instance. You can specify, for example, 0. That means not all of them. 1. If you said the minimum 1, that means we have a total participation, right? Because if you said the minimum value is equal to 1, that means we have a total participation, because at every single instance must participate at least once. So in this case, total. Yeah? If 0, that means partial participation, right? Because the minimum number of entity instances are going to be participating in this relationship is going to be 0 in this case, not all of us. Oh, then partial participation. Clear? The other one we talk about here, how about the maximum, the highest value? So the maximum here, or the maximum cardinality, is the maximum number of entity instances that can participate in the relationship instance or relationship instance. Here you can specify the highest value. For example, you can say the advisor can advise at most 3 students, so we can have the number 3. Yeah, or n. Generally speaking, it might be 0, it might be 1, maximum, it's not 0, the value maximum 1, 2, 3, 4, m, or star. If you use a star, that means unlimited. But here, most of the cases, you're going to use m or n, okay? You don't specify how many times. So the maximum value of 1 indicates that, what if I have the minimum 1 and the maximum 1, for example? 1, that means total participation. 1, that means in this case, the entity participates in at most 1 relation. This is the maximum value, okay? If you use, for example, a star, that means unlimited, or they indicate no limit. But most of the cases, you're going to use m or n. This is your choice. That means any number. Okay? Clear? So we have the minimum or maximum value, or they have the low or the highest value. Okay, either it's gonna be fine here. And you just to you're supposed to have the the minimum maximum to specify that. Each of them is gonna have the low value and the high value for each of them. Okay, let's have examples better here. So assume that we have instructor and student. I'm planning to say what the instructor can advise 0 or more students. Okay, a student must have, let's say, one advisor and cannot have multiple advisors. So what does that mean in this case? So instructor can advise 0 or more students. Okay, so we have the minimum is going to be, the low value is going to be what in this case 0, and the highest value is going to be star. Okay, I know the previous slide I used minimum and maximum, but actually we're gonna, the low value or the highest value, each of them is gonna have the minimum and let's say up to the maximum value, or the low or the high. Yeah, if you want to specify that. So anyway, so what's the minimum value of this case? 0. Let's say instructor advise 0 or more. 0, oh, come on. 0, please. 0 or more. I didn't specify the high low. Okay, so here just indicate the instructor that's advice. Okay, so here the student, we said, must have one advisor and cannot have multiple advisors. So the minimum value, we said, must have one advisor. Minimum value in this case is going to be, the low value is going to be 1, and the highest value is going to be 1. We said and cannot have multiple advisors. So total participation in this case. Here partial participation. All right. So what's the relationship here? You think between the from the instructor to student, or the cardinality, is 1 to many or many to 1? So what do you think, guys? 1 to many or many to 1? Okay. Let's analyze this one. It's going to be 1 to many. Okay. Why? Someone will say, but we have a here star and we have 1. This is just to tell me this one is going to be participating in this relationship. But in talking, the cardinality actually going to be the opposite direction. And they're going to show you why in this case. We said here the instructor are going to have what? Can be 0 or more. Advise more, 0 or more students. Yeah. So it might be more 1, 2, 3 students. All right. And we said the student must have one advisor and cannot have multiple advisors. So in this case, this situation, we cannot have this. It's not allowed. So the relationship is going to be 1 to many. Clear? Clear, guys? What do you mean 1 to many, many to 1? Why we have this case? Good. So all is going to be the opposite here. So we take a look, whatever, sometimes we got 0 to say to m, and 1 to 1, this is, in this case, 1 to many in this case. Okay, so you need to specify the low value or the highest value. So what have I said here? Just for example, assume that the instructor can advise 1 or more students. So 1 and more can be something like this. 1. So in this case, to be total participation in the instructor and total participation of the student. Right? So what else we have here? How about the cardinality that concerns in the ternary relationships? That we have the relationship that have more than, is not binary relationships. So the binary relationship set is going to be something different here, okay? So in this case, assume that we have entity set A, B, C, okay? 3 of them. 3 entity sets. And we have a relationship R. Here we said we limit here the number of one side, or one, either say one side, the relationship is going to be one, and there's going to be many to only to one, let's say, entity set. No more. Why? After that, it's going to confuse us. It's going to make things not clear. Okay? So again, we've said here the error that we have, if you assume that the project guide, the same example that we did before, or here just to generalize the process A, B, C, okay? If you have more than one line, or want to say one error, when I say one error, that means we have more than one entity set, it's going to be, have what? One. Okay? 1, 2, something. So in this case, it's not easy for us to not specify and come up with the right or correct meaning here. So let's take a look here. Assume that we have like ternary relation, that's given here, and we have an error to B and C here. What does it mean, error B and C? That means in this case, we have one side here, here one, and here one. And here there'll be many. So in this case, we have many options. You need to elaborate to figure out how can you figure out the relationship out looks like. So either, or in other words, say each A entity, in this case, okay, it's going to be associated with the unique entity from B or and C. Because here we have one entity instance from A can be uniquely associated with one entity's instance from B and C. Right? Because you have 1, 1. Okay. The other implementation or interpretation here, we said each pair of entity from A and B, each pair, one value from here or here, it can be associated with unique C. Or each A and C is going to be unique, associated with unique instance from B. Why? I cannot decide because they have many ways to do that. So right now we have 3 different ways to interpret this one. Which one is the correct? But if we have one error, so that's means one-headed, that means we have only one relation or entity set participated ternary relationship as one side. So in this case, it's easier for us to have interpret this one clearly. I can say, for example, assume that we have only one error from, let's say, R to C, and the rest is going to be many. So in this case, you're going to say one entity, or to say instance from A, B can associate unique uniquely with, they say, one entity or one instance from the entity set C. I'm not going to confuse you here, but if we have ternary relationship, we limit the number of the errors. It's going to be only one. So one of them is going to be have the one side. Otherwise, we cannot, you say, interrupt this one correctly. Okay? We talked about the keys before. So we know what to mean the primary key, the super key, the candidate key. It's have the same definition. Okay? I need just to add one thing here. The relation of the entity set that doesn't have or possess, let's say, sufficient attributes. Sometimes you're going to end up one relationship, okay, or entity set actually, okay, which cannot stand alone. It needs help from another entity set and going to be identify every single instance of this entity set. We call this one the weak entity set. So again, if they have an entity set that contains enough or have, let's say, a primary key, we call this one a strong entity set. If not, we call this one weak entity set. How can you specify this one? You are going to take a look to the attributes that associate or store every single entity set. Then you see, do we have a subset of attributes that can uniquely identify any instance within this entity set or not? If yes, then that you can consider this entity set as a strong. If it's not, that means this entity set cannot stand alone, needs help from another entity set. So in this case, we call this entity set weak entity set. Okay? So now we need to specify, how can I specify what the primary key of the entity set, the relationship set, and the weak entity set? Because we need to specify the way in order to distinguish, say, an entity set, or say, instance that's stored with the entity set. At the same time, we need to specify, to say, uniquely distinguish or identify the instance within each relationship set, right? And etc. So I'm going to take a look and show you that the way, how can you specify the primary key for entity set? I'm talking about the strong entity set, then you see the weak entity set, then after that with the relationship set, in the middle. So the primary key for the entity set is easy, okay? The only thing you try to find this, this is a subset of attributes that uniquely or suffice to distinguish entity from each other. When you talk entity, it means entity instances from each other, from on the same entity side, right? So that's easy to find with ID, name, etc. So how can you specify the primary key of the, let's say, the relationship set? The relationship set has different ways in order to specify the primary key, okay? So I prefer maybe use this, yeah. I need to go to the whiteboard to go over this one a little bit. So I will give you example. Assume that we have a relationship set, that contains attribute A. I don't know what's this. Eiffel Tower, maybe. We have A, and we have a B, and this relationship. Maybe we have another one if you want, just to give you an example. Okay. Then, in order to specify the relationship set attributes that's stored in this relationship set, I need to figure out, the set of attributes that's stored in the relation R, or the relationship set R. How can I specify that? First, you are going to find out all the attributes or the primary key for all, let's say, the entity set that participate with this relationship set. So here we have A and B participate in R, okay? So give me what's the primary key of A? Union. What's the primary key of B? If you have another relation, you can say what's the primary key of that one. So I need just first, in order to find out the primary key of the relationship set, I need to specify or identify what's the attributes that can be stored in this relationship set. How? All the primary key union, all the primary key of the entity set that participate in this relationship set. Union. Something else. Do you have any descriptive attributes that associate with the relationship set or not? Assume that we have, okay, A1 up to AN. Something else. Oh, let's say A1 up to AN. Okay, we have some descriptive attributes associated with this one. So in this case, you're going to say A1 union up to AN. Okay? So far, so good. Do you have a problem here? This is the way how can we identify the set of attributes that will be stored in the relationship set. Good? Now, after you specify the set of attributes, now we need to specify how can you define the super key instance. The super key of the relation R consists of the union of all the primary key of the entity set. So I take a look here. This is the set of attributes, union of all the primary key of the entity set that participate in this relationship set. We call this one the super key of R. Right? Then now, I need to identify the primary key. To identify the primary key, it depends on what? It depends on the mapping cardinality of the relationship set. What does that mean here? I need to see whether many-to-many, one-to-one, and etc. So in this case, it depends on the mapping cardinality in order to specify which one is going to be the primary key. Let's repeat this one again. In order to specify the primary key for the relationship sets, I need to follow the following step. First, I need to identify what the set of attributes that will be stored in this relationship set. How can I do that? I need to do first union all the primary key that every single or the union primary key of the entity set that participate in this relationship set. In our example here, we have A and B. So we have only two entity set participate in this case. If you have a more, just list out all the primary key of this relation, of the entity set. We end up this one. Union. Do you have any descriptive attributes that associate with this relationship set or not? If yes, add them here. So this is all going to be all the what you have right now is what is called a set of all attributes that be stored in this relationship set. Clear? Great. Then now I need to specify the next step. You have to tell me which one is going to be the super key. The super key is going to be a union of all the primary key of that you collected, or let's say that belongs to what's called the entity sets that participate in this relationship set. How can I define now the primary key? The primary key is not easy. It depends on what? It depends on the mapping cardinality of the relationship set. So in this case, we have many options. The first one, if we have a many-to-many, and in this case, we have a many-to-many, right, from A to B, from the relationship set R. So that means you're going to do what? You have the primary key is going to be the union of the primary key that was for the entity set, or the many side of the entity set. So the primary key in this case is going to be public key of A, union public key of B. This is my primary key. If we have one-to-many, and here it's from A to B, okay? I'm talking about the relationship from A to B, of the mapping cardinality from A to B. Is one-to-many. Then in this case, the primary key is going to be what? It's going to be the public key of what? Of the many side, which is going to be only B. So that's what, of course, public key A is going to still be an attribute that's going to be associated, going to be stored in the relationship set R, but it's not going to be a primary key. Clear? If we have many-to-one, so this means from A to B, many-to-one. So the primary key in this case is going to be the public key A, because I'm always go with the many side. If all of them are many side, all is going to be the union of their, primary key. What if we have one-to-one? Or one-to-one from A to B? Now your choice. Choose either of them. It depends on you. Whether you're going to choose the public key of A or B, either is fine. Why? Because here in this case, if you have a many-to-one here, that means many of them. Why in this case many-to-one? I need to choose the many side here. So you have from A here and B and the relation R. When I say many-to-one, that means here something like this here. So one attribute A is going to be associated, one attribute, we'll say, an instance B is going to be associated with any number of A. And one of A is going to be associated at most with only one. So basically, the value of the many side, I can uniquely identify any, let's say, relationship instance here. Because based on the attributes of the public key of A, I can uniquely identify any instance in this case, on this relationship set. I'm not going to go with the one that maybe repeats many times. This one, based on the value of A, I can tell how can I specify my data. Because if you rely on B here, use in this case many-to-one, and the rely on B is used as a primary key in this relationship set, now B cannot uniquely identify this one because maybe you're going to associate it with multiple instances of A. So I cannot tell in this case, right? So anyway, that's why we have to go always on the many side. If you have only one-to-one, that means your choice. You can choose whatever you want as and use as a primary key, which can be summarized in this slide. Okay, this is going to be slide 61, and I guess maybe the next slide is going to summarize this one more details. This is clear, guys. I know it's too much we need to cover today, but hopefully if you understand this one, things can be much easier because you can practice them. Great. So this is slide 6. That's what I talk about right now here. We specify the set of attributes first. If you have this set of descriptive attributes that associate with this the relationship set, add them as a set of attributes. But keep in your mind the super key only the union of the primary key of the entity set that participate in this relationship set. In order to decide which one is going to be chosen as the primary key, all of them is going to be there, but which one is going to be primary key was based on the mapping cardinality. Always go with the many side. If you have one-to-one, your choice. Which one are you going to use? It depends on you. Okay? Now back to the weak entity with something, strange here. Sometimes you end up with the situation that we have a set of attributes that cannot, or the entity set cannot stand alone. Let's have an example here. Assume I give you a section entity, okay? You have a section here. What do you say section? And we have, for example, here course. Okay? And inside the section entity, what the attributes is going to be identified in this one? In order to identify any entity within this entity set, we need to have the course ID, the section ID, and we do have, let's say, year, semester, and year. When you see the section ID, it's gonna be, for example, the CS, CS 4 to 5, the section ID 1, and the semester summer, for example, and the year 2021. Then we have CS 4 to 5, the section 2 for the summer 2021. And we have CS 5 to 5, we have the section 1, the summer 2021, and etc. You take a look here, you see that in order to uniquely identify any data here, I need to have the following information. This is amazing. I'm relying on the course ID and the section ID, the semester and year together as one unit in order to identify any entity within this entity set. Correct or not? Do you agree with this or not? Actually, see this one. If you rely only the section ID, semester, year, you see that we have this summer, for example, I'm teaching 3 courses. So we do have, one summer 2021, and there's one summer 2021. But one of them belongs to the CS4 to 5, and the other one belongs to the CS5 to 5. So without the help of the course ID, I cannot uniquely identify any tuple within or an entity instance within this entity set. Clear? So in this case, what if, okay, we do have like a relationship set called section course, which is going to be capture the relationship between the section and the course. So one thing here, so you have here the section. Okay. So in this case, what kind of attribute we need to store in the section course here? I'm going to take the course ID, and I'm going to take all the attribute, the key of the public key of the primary key of the section. Within this case, it's going to be course ID, section ID, semester, year. If I do this one, that means, oh, there's a duplicate information. That's not good practice. So maybe in this case, one option to deal with this redundancy is do what? I'm going to get rid of the relationships, section course. I don't need it. But if I remove this one here, now it's going to have a course in one place, and we have a section in another place. I cannot capture the relationship between them, which is not desirable. You see the problem here? So how can he handle this situation? So one thing, I don't want to raise whatever. Anyway. So anyway, in order to deal with this redundancy, I'm going to say what? I'm not going to store the course ID here. Because the problem is you keep this one, the course ID doesn't belong to the entity set per se section. It belongs to another entity set. So why you include this one as a primary key? Why you need this one? So in this case, if you have this situation here, so I'm going to say I'm not going to store the course ID in the section. But if I didn't store that, I'm going to have a problem because I cannot uniquely identify any tuple or any entity instance for the entity set section, because I am going to end up, we have what? The section ID and semester and the year. So we have one, let's say, summer 2021, and we have another one, summer 2021. Actually, one belongs CS4 to 5, and the other section belongs to CS5 to 5, and more. So in this case, in order to solve this problem, I'm going to do something different. I'm going to treat the relationship set. I will keep this one, okay? I'm going to say we do have a relationship set. It's called section course, okay? I'm going to use this one as a special relationship. That's what that provides special or extra information to the section in order to uniquely identify this one. So in this case, if you go back here. So in this case, I'm going to keep this one. Remember, we have the course here. And we have, let's say, the section here. And then here, I'm going to keep this, the section course relationship. But in this case, I'm going to say something here. I'm not going to include the course ID here. No, I'm not going to include this one. because this one the primary key valorization, so it does make sense here. So here it's going to be the course ID and the, for example, title, information about the course. Here I'm going to keep the section ID as the semester and the year. Okay, then I'm going to say here, this relationship set is a unique relationship set. It's used in order to provide me with an extra piece of information. What kind of information? It's going to provide me with the course ID, which is going to help me in order to uniquely identify any instance within this entity set. So how can you specify that to the system? This is going to use double diamond. That means here something or this identifying the relationship set, which is going to tell me, for example, you have to follow this or give you a connection, or we use this one in order to get help from the strong entity in order to define or uniquely identify or help or in order to build the primary key for the weak entity. So weak entity is going to be double rectangle, okay, which contains only the list of the partial keys or the part of the set of attributes that needs help from the strong identity or entity in order to uniquely identify any two of those relationships or entity set. Make sense here? So in other words, sometimes you end up with have one entity set that cannot stand alone, which require to have the primary key from another relation or entity set actually in order to have this entity set or the weak entity set and uniquely identify any instance within this entity set. Cannot stand alone without the help. How can you capture that? I'm going to do this one using the weak entity here. So it depends on your design. You might have one entity that can be weak, which cannot stand alone. Okay? So this is how it looks like, something like this. So here we have a course, we have a section, and if you take a look, you see this one again, say, oh, it looks like this is weak entity. Why? Because based on the attributes that listed here, it's not enough. You cannot uniquely identify or distinguish between two different instances within this entity set, which makes sense. Course section ID 1, semester spring or summer, year 2001, and we have many courses, we have different sections in the same term. Without the course ID, we cannot identify them. Okay? And this one must be many to one. Okay? From the weak entity to the strong entity. And this is the way how can we specify that. One thing I need to add here, we do have a set of attributes here that's going to be listed in the section. We call this one the discriminator of the weak entity, and we use this one to underline them by or with the say a dashed line. What does that mean here? We call them are the partial key with a set of attributes that is going to be belongs to the weak entity, which by the help of the primary key of the strong entity, it's going to uniquely identify any instance within this entity set. Maybe not all of them are going to be discriminator. Okay, it depends. Okay, maybe not all. In this example, all of them are going to be discriminator. That means we call this one the partial key. That means in this case, if you give me the primary key for a strong entity plus those partial set of attributes, I'm going to be able to uniquely identify an instance within this entity set. Okay? So the primary key in this relation here, we're going to see this is going to be what? It's going to be the cost. Yeah. The primary key is going to be the course ID, the section ID, the semester, and the year. All of them are going to be the primary key. You cannot say course ID. Can the course ID going to be the primary key here alone? No, remember it's going to be CS. Give me an example. Nice thing you have example with an instance of the data, how it looks like. CS. My computer refused to type anything. Maybe it's try. So you have CS 525. Section ID is going to be 1. Semester, I'm going to use summer, for example, year 2021. CS 525 2. And I don't know what's happened here. Come on. Why I can type here, but I can't type here? Does make sense, right? Again, I will try again. So it's gonna be 5 to 5, 1 summer 2021. 5 to 5, 2 summer 2021. 4, okay, 4 to 5 to continue with the data, 1 for summer 2021. You see that it's not enough to rely only on the course ID, not uniquely identifying it over here, right? Or instance here. Because if we have 25, we maybe have multiple value of 25. Assume that we have 4 to 5, section 2, summer 2021. So basically, course ID is not enough. Can you use the course ID and the section ID, not the unique identifier any instance here? No. CS4 to 5, 1. Maybe we have CS4 to 5, 1 over previous semester. So this case, not enough. Do you have the summer or spring? No. So that means you're going to add the whole thing. That's why in this case, you're going to say this is the primary key. All of the data going to be the course ID, the section ID, semester, year. Since I'm going to use the section ID, the semester, year, it's going to be part of the primary key. So in this case, we call this one discriminator or the partial key. Okay, so we have to underline them with the dashed line. These notations are going to help us later. When you translate this one, I thought I'm going to do this one today, but it's okay. Next lecture, we'll translate this one for the relational model that we have into the corresponding, the ER model or diagram into the corresponding relational data model. You see that I'm going to use this information. If you have a dashed line, you're going to say, oh, this is going to be part of the key. So when you define the primary key, I have to include them in the part of the primary key. Okay? So this is how can we express the weak entity here. Sometimes, with the last part of the phase 1, okay? Sometimes you're going to end up, we have some redundant attributes. What do you mean by redundant attributes? So assume we give you this relation, or the entity set. In this instructor, what we said, what kind of information we need to install in the instructor? We need the instructor ID, name, department name, and the salary. And for the student too, we need to have information about student ID, name, department, etc. Yeah, those kind of information, maybe we're going to collect them here. So what we notice here, if we have this situation, okay, when you end up, we have, for example, a relationship set, which is going to be capture the relationship between two entity set, and you're going to see that if the relationship, by the way, is going to be many to one, find out that we have, like, let's say, the primary key of one entity set, and going to be like an attribute of other entity set. Take a look here. The primary key is the department name. I use this one here as the department name. It's going to be an attribute. Why this is redundant? Let's take a look here. What kind of attributes going to be stored in the instructor department here? Can you specify what attributes are going to be stored in the instructor department? I believe this is the last question for today's class. Today's lecture. Okay. So the attribute is going to be what? The primary key of the instructor union the primary key of the department, right? We've said that before. So primary key is going to be ID and the primary key of the department name. Okay. What's the primary key we're going to use here? It's going to be the ID here. So what happened here? It looks like ID, and this one's going to capture the ID, the instructor ID, and the department name. But inside the instructor, I already have the department name here. So in this case, what happened here in this case? Looks like we have something wrong here. So we have one extra attribute. So since the attribute department name appears in the both entity sets, okay, and in one entity set it's going to be the primary key, in the other it's going to be part of the attributes here. So this situation we have, so in this case, I'm going to eliminate this one because the department name, there is no need to be here because I'm going to capture the department name, the relationship with the department ID using this and let's say relationship set. Someone maybe asked the question and said, but I remember when you work with the instructor, I remember that the instructor already have the department name. So how come? Later, when you translate this one to the corresponding relational data model, we're gonna do what? We're gonna combine this let's say relationship set with the instructor. So we end up, we have the department gonna be part of the result. But right now, since we treat this one as a redundant attribute, so we are not allowed to have this entity, or this is gonna be part of the instructor and attributes. Clear? Make sense? Make any sense? No? Okay, great. So now that what we have, we're gonna end up something like this. If you take a look here, you have a department, an instructor, student, and etc. Those kind of the strong entity set. So this is strong, 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 and this is strong. Sorry. Okay? And those diamonds are, say, the relationship set, right? And here we see that descriptive, some of them takes gonna have the grades gonna be associated with the relationship set. Okay, here we know the section is gonna be a weak entity set. Why? Because they have a double diamond here. So who, by the way, can you specify which one is gonna be like the strong entity set used in order to identify this weak entity set? You follow that, what is gonna be the identifying relationship set. We're gonna tell you this one. The reason we have section course here, just to tell us that here, go to the course, take the primary key of the course in order to help you to identify an instance within this entity set. Okay? This is what one special case, what we have one attribute, then after that, this attribute will be the primary key, at the same time, there will be composite attribute, at the same time, there will be multi-valid attribute. So yes, we can do this one. So that's what I expect from you, something like this. Okay? Great. So that's what I expect from you to do in the phase one. Read whatever you have and give me something like this. And you can use whatever you want, okay? Whatever your notation you prefer. Either using this one, using ML, or maybe use the other notation that uses oval. Remember the oval, for example, let's say he's going to say for the student, we're going to say the student here. And you can say this is the ID, this is, name, and this is, say, for example, total credit. Something like this. It's fine with me. Okay? Here, just I want to add, if you wanted to specify, then let's say, take a look at the time slot. So we do have what here? We have a time slot ID with the primary key. And here we need to specify composite attributes. In the composite attributes, let's say here we have like day, oh, sorry. Give me a second. Sorry. Yeah. This is time slot. We do have what? We have a time slot ID, which at the same time is going to be composite attribute. We have a day. We have a start date, for example, or start time. And we have end time. And at the same time, it's going to be multi-valid attribute. So it's going to be double oval in this case. That's the way how to do that. If you want to use this alternative way in order to represent or in order to come up with the data or with the database management, whatever design that we have. Now let's take a look at the different story here. Reduction to the relational schema or relation schema. So I will stop here because I believe we cover a lot of material today. And the goal for me, make sure that we understand what's going on. So please take a look whatever we cover today. And the takeaway from you that I want from you to focus on, start with the class project and start identifying what entity do you have. Find the entity sets that you have, relationship sets. Then after that, try to find the relationship among them. And try to specify what kind of attributes do you have for every single entity set. That's what I want from you in this part. Then draw this one somehow. Next week, we're going to take a look at something different. I will start with this one and try to generate or create a schema which is interesting. I mean, the hard part that how could you build the phase one, which is a confusing one because we need to take a lot of entities, sets, and etc. Weak entities sometimes, how to handle them, and so, but the rest is gonna be okay. Okay, and the reduction, we have a set of rules, we can follow them, and we can do that easily. Okay, so if you don't have questions, guys, this is the all for today. Thank you. See you, I mean, next week. If you have any questions, I will available tomorrow during the office hour, or you can just send me email. Okay, thanks, guys.